Hi there. I'm Simon, and we are the team forming the project SafeAya and present our project to making the AI model safer. Next slide, please. So yeah, the main focus of our project is studying the jailbreak in the multilingual context, and the first half of our presentation will focusing on investigating the vulnerability of models, including Aya and also Llama under the popular kind of jailbreak attack methods. And our finding is the Aya model is still highly vulnerable to jailbreak. Next slide, please. So in corresponding to that, we also proposed that a way to train a safer Aya model to defend this attacks and achieving a more robust Aya model. Next slide, please. So here are the three objectives, or you could also say it's the research question that we set up at the beginning. So we wanted to study the vulnerability of open source models like Aya, especially under the multilingual kind of jailbreaking scenario. And the second point is one of our hypotheses is multilingual jailbreak would be more vulnerable if the model is having a better like multilingual capability. And thirdly, is related to, we also wanted to improve the safety and robustness of the model using the synthetic data that we will talk about it later. Bear with these 3 points. We'll come back to it later at the end of the presentation. Next slide, please. So yeah, here summarizes our contribution. So first of all, we explored how adversarial kind of vulnerable in multilingual models are, and as a contribution, we also released the data set publicly for the multilingual ADV bench that we translated using Google Translate, and also the generated data that helps to improve the robustness. And thirdly, we train Aya with DPO for more robustness against attack. Next slide, please. So yeah, let's talk about the kind of our objective for the definition of this jailbreaking is we search for adversarial prompt or suffix that could elicit the harmful behavior from models. And we also wanted to investigate in the multilingual scenario. So next slide, please. So we put our effort firstly into translating the ADV bench that originally kind of constructed 520 harmful behavior in English and then translate them into 23 language, same set as the Aya model. And we tested on the models, not the proprietary models, on Llama 3 and also the Aya models. So next slide, please. So yeah, the first kind of jailbreak techniques or the experiments that we try is the GCG attack, which used the gradient information about the model and to use it as a optimization to generate the ADV prompt. And by talking about this, I will pass to Nish to talk about more details.
Oh, Madeline, is it possible to inaudible? Sorry.
Yes.
Yep. Next slide, please. So yeah, next slide. I think this is for like the ADV prompter. Yep. So we first evaluated Llama 3.1 and Aya 8B on the multilingual ADV bench. That is like 23 languages across the entire 520 behaviors. So the bright red bar in the left is Llama 3.1 and the right is Aya 23. So the bright red bar is for English. You can see like Llama 3.1 is more likely to refuse harmful instructions, but the safety training does not generalize across all languages. You can see like high attack success rate, even like for baseline without any like GCG attack for like Turkish, Japanese, and Korean. Next slide, please. Yeah. So this is so first we start with the single harmful behavior. The bright red line is like for the English language, and for other colors are for the other language. We didn't want to show the entire 23 languages to clutter the plot, but you could see like we mainly first did not do for the entire 520 behaviors. So what we did was we picked only like 39 behaviors that are like more likely to be refused, that were refused by Llama 3.1 across all 23 languages. So we'll have like a good test of baseline that how GCG encourages to attack. So we could see like for English, we did run for 250 steps, and we did try 30 different behaviors. Llama 3.1 is cannot be jailbroken in English. The loss never goes down by a lot. It increases maybe after like few around 4,000 steps. It may be like across like hundreds of different runs. Maybe the attack success rate is like 1% or less than that. But it corroborates with the story that a Meta specifically adversarially safety trained Llama 3.1. And that could be seen that. But the Meta claims Llama 3.1 is multilingual. It does not the adversarial safety training for English does not translate to other languages. We could see like the loss for other languages specifically reduces really low, and it did increase the attack success rate. And similarly for Aya, we could see like specifically for specific languages that is not present in Llama 3.1, but Aya, the robustness is higher. Next, please. Next slide, please. So yep. Next is the multiple harmful behaviors. So this is for 25 behaviors for English attack success rate, and there's also extra information for like 5 behaviors for multilingual. We could see as in the previous slide, Llama 3.1 the attack success rate is only 0 to 4%. This is for 1,000 steps, so it's very long. But the extra information is for multilingual for 5 behaviors. Llama 3.1 8B is like 70%. So that's a very high attack success rate, and it proves that adversarial safety training for English is not sufficient for a single language. We have to perform it for multilingually as well. Next slide, please.
So yeah, due to the time, I'm not going to explain about the ADV prompter, but this is the kind of the figures to illustrate how it works. Next slide, please. So basically, our results shows that the Aya model are still very vulnerable, having 73% of the jailbroken rate compared to 24% on the Llama 3 model. Next slide, please. And we also see that this could be transferred to other model, including the Command R and also the Command R plus, and leading to around 60% of the jailbroken rate in the top 1 and 96% in the top 10, which is worrying. So next slide, please. And yeah, so basically the way that we try to defend this is, next slide, please, via the DPO. So we use the Aya model that got jailbroken, and also including the OpenAI, the ChatGPT, to as the chosen prompt. So next slide, please. And next slide, please. The same one. So yeah, basically we see on the fourth bar on the right-hand side, we see a much lower 95% more safety compared to the original Aya model. And on the left bottom corner, we also proved that our SafeAya not kind of having the false refusal rate and maintaining a even slightly higher uppercut eval to that doesn't lose its general capability. Next slide, please. So yeah, the multilingual, we are still working on that. So next slide, please. So yeah, basically to wrap up, we managed to study the vulnerability of the multilingual model. We didn't kind of finish the hypothesis define, and lastly, we haven't done the defenses for multilingual data, but we proved the alignment in monolingual data to improve the robustness. Next slide, please. Next slide. Yeah, it's just some future plan. We are continuing doing that and drafting a workshop paper. Next slide, please. So yeah, thank you. Here is our kind of data set, model, and code that is all available in Hugging Face and GitHub. And special thanks to Jiang Yi and Marcia for helping out this. Sorry for the overtime. Yep.